Let's talk about the weighted average cost of capital, or WACC. The weighted average cost of capital is the firm's overall cost of capital based on the components of its capital structure. And we see here that our first term is the required return on equity, and we're multiplying it by a fraction that represents the proportion of the capital structure that is equity. In fact, we see that V is equal to D plus E, and so this is just E divided by D plus E. Over here we have the term that represents debt, and this is the proportion of the capital structure that is debt multiplied by the required return on debt, which would be the weighted average yield to maturity on all the firm's bonds, multiplied by 1 minus T, where T is the marginal corporate tax rate. Now, why do we do that? It's because debt requires the payment of interest, and interest is considered a cost of doing business, and so it is tax deductible. And so we multiply by 1 minus T here because we don't have to pay taxes on any money we spend paying interest. That's not true, though, for dividends or the capital gains coming from an increase in the share price for our stockholders, and so there is no tax add-on here for the required return on equity. Sometimes in problems you will see them talk about the after-tax cost of debt. That would be this entire term. If they do that, then you don't need to multiply by 1 minus T. However, if they give you the yield to maturity or before tax cost of debt, they're talking about this R sub D, and you will need to multiply by 1 minus T. Now, something else I'd like to point out here is that these weights add to 1, and they always will. So we're going to say E is over D plus E plus D over D plus E is equal to D plus E divided by D plus E. And that is equal to 1 because these things cancel out. Now this gives us a handy tool because sometimes the problem will give us everything except for the weights, and then will ask us to calculate one or the other. And the way that we do this is we set one of them equal to x and the other one equal to 1 minus x, because after all, we know they add to 1. Let's say that they are asking for the proportion of the capital structure that is debt. So we're going to set it equal to x, and then we are going to set the proportion of the capital structure that is equity equal to 1 minus x. And so our formula would look something like this. And all we would do is solve this equation for x, which is easily enough done. Then, once we find x, of course, we can immediately find the other weight if needed. And we could actually find the debt-to-equity ratio here would just be equal to x divided by 1 minus x. Let's see why that's true. It would be equal to d over v divided by e over v. And what happens is these v's cancel out and just leave us with d over e. And sometimes if a professor is feeling extraordinarily cruel, they will ask for this debt-to-equity ratio, and all you have to do is take this thing one more step and you can get there. One other thing to note here is that T, as T goes up, usually we think of taxes going up as a bad thing, but it actually reduces our weighted average cost of capital. Let's see why that is. 1 minus T, we're subtracting the T. And so as this T, which by the way we must use a decimal, not the percentage, let's say it's 1 minus 0.25 gives us 0.75. But what if taxes go up to 35%? Then we're looking at 1 minus 0.35, which leaves us with 0.65. So this term actually gets smaller the higher your taxes are. At 100% taxes, which I hope we never see, but at 100% taxes, this entire second term just goes away because every bit of the interest that you pay is tax deductible. Now let's talk about where we get the required return on equity. The required return on equity is going to come from either the security market line or the dividend growth model. Well, how do you know which to use? It's a matter of looking at what you're given. So what I'm going to do is look at the information they give me, and that will tell me which method to use. If they're giving me the risk-free rate, beta, the expected return on the market, things like that, I know I need to use the security market line. However, if they're giving me things like D0 or D1, G, and P0, things like that, then I know I'm dealing with the dividend growth model. What if they give you enough information to calculate both? Well, go ahead and calculate both, add them together, and divide by 2. Keep in mind that everything we do in finance is merely an estimate. And by having 2 estimates here and taking their average, perhaps we are actually getting closer to the truth. Now, where do we get R sub D? It's just going to be the weighted average yield to maturity on our bond issues. So let's use some fancy math stuff here. This is called sigma. It stands for sum. And we're going to say I is equal to 1 to n, where we have n number of bond issues outstanding. So if we had 3 bond issues outstanding, we're going to be looking at bond issue 1, bond issue 2, and bond issue 3, and adding them all together. We're going to have the weight on the issue, which is going to be based on the market value or price of the bonds, multiplied by the yield to maturity on the issue. And so how do I figure this weight sub I? It's going to be equal to the market value for bond issue I divided by the overall market value for all the debt. And so for each one of these, once again, remember the weights always have to add to 1. So I'm going to calculate those weights, and for each of those bond issues, I'll have a yield to maturity, or I will be given the information necessary to calculate a yield to maturity. And so for each one of these, I want to find the product of weight times yield to maturity, and then sum all those together. And that gives us our required return on debt. Okay, let's have some fun solving this for different variables in the equation. Let's start with RE. And I'm going to flop sides here, as is my usual practice. I'm going to start with RE on the left, and that's equal to RWACC, WACC. And then I'm going to have to subtract this term to get it on the other side. Okay, now all I have to do to get R sub E by itself, actually I have to do 2 things. I have to multiply everything by V and divide everything by E. Now notice that something fun happens here. These V's cancel out, and what they leave us with is the debt to equity ratio. And what we have over here, value, the total value of the firm divided by equity, well, that is the same as our equity multiplier. So if you know your financial ratios, you're already familiar with these components for the formula for the required return on equity, given all these other variables. What if we want to solve this for R sub D? Well, we need to, first of all, flip, as we always do. Now to get this on the other side, I'm going to subtract E divided by V times R sub E. Now to get R sub D by itself, there are actually 3 things we need to do. Number 1, we need to multiply everything by V. Number 2, we need to divide everything by D. And number 3, we need to divide everything by 1 minus T. So I'm going to do all 3 of those things at one time. I'm going to multiply everything by V over D times 1 minus T. So we can go ahead and do some canceling here. So what we have here is the inverse of the debt to equity ratio. So let me clean this up. R sub D is equal to V times R WACC divided by D, 1 minus T, minus E over D times RE 1 minus T. So there is our formula for the required return on debt. We could simplify this further by factoring out this 1 over D times 1 minus T from both of these terms. We have one thing left to solve for, and that is T. Let's solve for T. And if I want to do that, what I'm going to do is subtract E over V times RE from both sides. And of course, I'm going to flip as I always do. What this time we're going to do is multiply by V and divide by D and R sub D. Notice that as before, the V's cancel out. And now we have one thing left to do. We've got to get this T by itself. And notice that the T is negative. And so what I'm actually going to do is add T to both sides and then subtract these terms from 1. So this term had a negative previously, now it's a positive. This term had a positive previously, now it's a negative. This term had a negative previously, now it's positive. And this term had to cross the line, and so it became negative, but then everything is negative of what it used to be. I could have started out here by multiplying all of these terms by -1 and then moving the 1 over. Now we have the weighted average flotation cost. When firms issue new stocks or bonds, they always have to pay flotation costs, which are the cost to get an underwriter or investment bank to help you issue these items. And so this is a real cost that we need to think about. And we usually use the weighted average flotation cost for the firm based on the firm's current capital structure, regardless of which kind of security we actually plan to issue. Because after all, in the long term, we are planning to maintain our target debt to equity ratio. And so if we went this time with debt, next time we might have to go with equity to try to stay within our acceptable boundaries on our capital structure. So let's talk about what these different things mean. F sub 0 here is the weighted average flotation cost. And I want you to notice that these weights are identical to what we've been seeing so far. And once again, the weights add to 1. And we're multiplying the proportion of the capital structure, that is equity, times the flotation cost on stocks. And then we are going to add the proportion of the capital structure, that is debt, multiplied by the flotation cost on bonds. Now, because of the increased risk of a value change or the uncertainty in what the true value of the stock is in the case of an IPO, the flotation cost on stocks is higher than the flotation costs for bonds because bonds have a set promised series of payments. At least we have that down, and we probably have a pretty good idea of what the required return is. So it's a lot easier to price these bonds, and therefore the investment banks are not bearing what we call inventory risk nearly as much for these bonds as they are for stock. Let's solve this thing for F sub S, the flotation costs on stocks. And as my usual practice, I'm going to flip sides. I'm going to subtract D over V times F sub B from both sides. And now we can multiply everything times V over E to get F sub S by itself. Notice here that the V's cancel out and we are left with the debt to equity ratio. And over here we have the value divided by equity, which is actually just the equity multiplier. And so this is similar to when we were calculating the required return on equity. One thing I want to point out here is that there is no 1 minus t on the flotation cost for bonds. That's because for tax purposes, the flotation costs on stocks and the flotation costs on bonds are treated exactly the same. And so there's no reason for us to have a differential equation treatment when there is no differential tax treatment. Now I want to solve this thing for f sub b. And that means, once again, I'm going to switch sides. D over v times f sub b is equal to f sub 0 minus e over v times f sub s. This time, I'm going to multiply both sides by v over d. And when I do, of course, it'll cancel out over here and leave f sub b by itself. Notice once again that the v's cancel out, and we are left with the inverse of the debt to equity ratio. And so this is how we would find the flotation cost for bonds. By the way, these are going to be probably stated as percentages in your problems, but you'll need to put them in here as decimals. You could actually do them all as percentages, but when you finally put them into the equation where you're calculating the dollars, you definitely need to use decimals. A good rule of thumb is to always use decimals when you're using them in a formula where you're multiplying by something, because otherwise you'll get into a lot of trouble. Beta is our measure of systematic risk. This is the kind of risk that we can't get rid of through diversifying our portfolio. And if we were looking at a portfolio, we would see that the beta for the overall portfolio would simply be a weighted average of the betas that are in that portfolio. Similarly, we can find the beta of the assets of a firm as the weighted average of the beta of the equity and the beta of the debt. And of course, the weights are the ones that you're familiar with, E over V and D over V, where V is equal to D plus E. Now let's talk about what these things mean. Hopefully you're familiar with the beta on stocks. That's what we use in the security market line. We rarely hear about the beta on debt, but we'll talk about it more in a second. And the beta of the asset, to me, is the most intriguing of these all, because the beta of the asset represents the risk, the systematic risk of the underlying assets of the firm. This is how the business is set up. And so this would have to do with the market that you're serving, the product you're producing, and the method in which you are producing that product. Because firms with greater operating leverage will have greater beta of assets. And so this is all some interesting stuff, and what we want to do here is go ahead and solve this thing for the different variables and see what we get. Let's start by solving for the beta of the equity, which is the one that we hear the most about. As is my usual practice, I will flip these things. And all I've really done is subtracted D over V times the beta of debt from both sides. Now I need to multiply both sides by V over E to get this to cancel out. Notice that the V's cancel out, and this leaves us with the debt to equity ratio and the equity multiplier, which we've seen before. I can clean this up a bit. And now let's talk about the beta of debt. Stocks go up and down with the market. And if a stock is equally risky as the market, it will have a beta of 1. If it's more risky than the market, it will have a beta of greater than 1. And if it's less risky than the overall market, it will have a beta less than 1. Now, what makes stocks so risky? Stocks are a residual claim, meaning the stockholders are the last people to get paid. But debt holders receive a set of fixed payments. Unless the borrower defaults on the bonds, then they will receive all those payments as scheduled. And so what we see is that the price of stock may go up and down with what's going on in the market, that the price of bonds is far less impacted. In fact, unless you're told a beta of the debt to use in your calculation, the assumption we usually make is that the beta of the debt is 0. And so the beta of the equity is merely the beta of the asset times the equity multiplier. Let's assume, though, that the beta of the debt is not 0, and let's solve for it. So I'm going to add d over v times beta of the debt to both sides, and so that's going to leave us with beta of the asset minus e over v sub b. What do we do now? Well, we'll need to multiply both sides by v over d, and it's going to cancel out on this side. Note that the v's cancel out, and we are left with the inverse of the debt-to-equity ratio here. And so that's how we would calculate beta of the debt if we were not assuming that it was 0. By the way, if you're asked to calculate the beta of the debt, or if you're given the beta of the debt, it is not safe to assume it's 0. But if you're not told otherwise, then you can assume that beta of debt is 0 and make the simplifying changes to the equation that we saw earlier.